All right, welcome back. So this is another ALEKS topic. It's called predicting relative forward and reverse rates of reaction. And this is a good topic. I think it gets us starting to think about the concept of equilibrium and sort of what it means to be at equilibrium versus what's going to happen if we perturb or change the system, how the system's going to react to that. I think that that's definitely related to Le Chatelier's principle. And this is just a good introduction to all of that. So let's go ahead and get started. I'm just going to do this one example for this. I think it covers basically all we need to cover. So in this case, it says we've got acetic acid and ethanol formed to react to form ethyl acetate and water. So this is just a balanced chemical reaction, and the concept here is that even though this is written as just a forward reaction, in fact, we're going to have both a forward reaction, so going from the reactants on this side to the products on the side. That's what we'd call a forward reaction. It's moving to the right. We're also going to have the reverse reaction occurring. So this reaction is going to go in reverse. It's going to go backwards, essentially, where the products every once in a while will react to reform these reactants. That's just the concept of equilibrium. We're going to be, having those competing chemical reactions occurring, in our reaction flask. So in this problem, it says that we're going to add some additional amount of the ethyl acetate. So this compound here, that's the ethyl acetate, that's this right here. And you don't need to worry about naming it necessarily, right? You just need to match up which one is this. It's this one here. So this is one of the products. So we're going to be adding in some product to a flask that's already containing a mixture that's at equilibrium. So the key thing to sort of pull out here, we're going to be adding some of this, which is one of our products, to a mixture that's already at equilibrium, and then we're going to sort of judge to see what's going to happen. So the first question here says, what is the rate of the reverse reaction before we add more of this into the flask? So we're sort of saying, we've got this system at equilibrium. What does that mean? What's going to be happening? And then we're going to change it. So before we do anything, the correct answer here is greater than 0 and equal to the rate of the forward reaction. So this is the whole concept of equilibrium, is that when these reactions get to equilibrium, the rates of the forward and reverse reactions are going to be the same. So it doesn't mean that, equilibrium does not mean that reactions have stopped. It means that the formation of the products is occurring at the same exact rate that the products are converting back into the reactants. So these reactions are sort of both going, but the rates of those reactions are the same. Therefore, the overall concentration of products and the overall concentration of reactants is staying the same. So we're not seeing any net change in that. So now we're going to add in that ethyl acetate, and it says, what is the rate of the reverse reaction just after we added more ethyl acetate? Well, if you put more ethyl acetate in, that's more likely that it's going to collide with these water molecules. It's more likely that it's going to reform these reactants. So the correct answer here is greater than 0 and greater than the rate of the forward reaction. So at the instantaneous time, right after we add that extra ethyl acetate, this reaction is actually going to move more back to the left. It's going to, essentially cause this reaction to shift back to the left because we've added in more of this product. So that's sort of the concept that we're trying to get at here. If you add in more of a one of these species, well, the equilibrium is going to shift essentially to counteract that. That's essentially Le Chatelier's principle, and we'll obviously be talking more about that as we move forward. What is the rate of the reverse reaction when the system has, again, reached equilibrium? Again, this is going to be equal to, right? That's the whole point of equilibrium, is that the rates of the reactions are equal. We're not going to get any net change between, the concentrations of products and reactants. Hopefully that makes sense. If not, just let me know. How much more ethyl acetate is in the flask when the system has, again, reached equilibrium? So this is asking us, in terms of this number here, we're going to add in 214 millimoles. It's saying, is all of that going to go away? Is all of that going to convert to reactants? Is none of it going to convert to reactants? What's going to happen with that? So the correct answer here is some, but less than 214 millimoles. So it's asking how much of this additional ethyl acetate is going to be left over. Well, some of it's going to turn back into these reactants, right? Some of it's going to go away. It's obviously not going to be more. That doesn't make any sense at all. And it's not going to be the same because it's gone that way. And it's not going to be 0 because it's not all going to go this way. So just a little bit of this, some of it's going to go that way, but some of it's going to be remaining. So some, but less than the 214 that we put in. Okay, hopefully that makes sense. Let me know if it doesn't.